Maybe. Part 2. Going back. So one thing I want you to know about a lot of the problems is that you don't stop. Don't stop when you find X. Don't stop when you find X. Plug it back in to find the segment. This whole unit, the difference between students who got A's and the students who got B's and C's. The B and C students stopped when they got to X. The A students were the ones who took the X and plugged it back in to find the segment. So I want you to know what the expectation is. It's to plug it back in to find the length of the whole thing. Next thing we have to know is the number line. The number line, a lot of you are going to be good with this, but I still want to say it just because. Smaller, larger. Number lines are interesting because some of you think of it in different ways. Let's go -6, -4, -2, 0, and 2. Let's do that. Here's my number line. And I have some numbers here. And I'm going to put a couple letters down as well. I'm going to put a P, I'm going to put a Q, and then I'm going to put an R right there. And we're going to do a couple problems with this number line, but I want you to think of something because a lot of students will not allow themselves to think like this, but I want you to think of it like this. Distance is always positive. Distance, I'm going to put a star next to this, is always positive. I can prove that to you very easily. I'm going to pretend Ariana's running around the track, and she has to run around the track, and she goes around 4 times, and she runs a mile. Okay, she ran 4 laps around the track, and then she goes, you know what? I'm going to go backwards now, and I'm going to erase the fact that I ran the mile. So she goes backwards 4 laps. How far did she go? So she actually runs 2 miles, right? There's no way you can convince me that that positive mile going forwards and the negative mile going backwards makes 0. Negative, there is no such thing as a negative distance. There's only such stuff as positive distance, no matter if you're going backwards or forwards. Same thing on a number line. Doesn't matter that we're on a negative side of the number line, the distance is still a positive distance. Keep that in mind. So my questions to you will look like this. PQ equals blank. QR equals blank. PR equals blank. And you can do this any way you want to. But if you get stuck, just write out what the number line is. PQ, how far is it from -6 to -4?
2.
That's the answer. Now, some of you might be making this more complicated. Why isn't it -10? Because you don't add the 2 numbers together. We want to know how far is it from here to here. It's 1, 2 spots. That's what it is. It's always positive. What about QR? How far is it from Q to R? 4. And how far is it from P to R?
6.
See you later.
Bye, Jimmy.
Bye, Jim.
So there's that. That's not the one I want. sometimes you're going to have to use a little bit of common sense. Let me show you a picture. This is like number 6. Number 6 has a picture and it says G, that's supposed to be a G, H, and I, like this. And it will say GH is 7y plus 3. It'll say HI is 3y minus 5. And it'll say GI is 9y plus 7. 9y plus 7 is this distance. Nine y plus 7. So what it's going to ask you for, it's going to say what's y equal to, what's GH equal to, what's HI equal to, and what is GI equal to. So what you're going to have to do is use some common sense plus some algebra to figure out what these answers are. Here's what I would do if I were you. This piece plus this piece should equal that whole piece. So we should be able to write an equation that says that 7y plus 3 plus the 3y minus 5 should equal the 9y plus 7. And then we could solve this and figure out what y is equal to. Let's put the 7y together with the 3y. Since they're on the same side, what is 7y plus 3y?
10y.
3, then minus 5 on the same side. 3 minus 5 is?
2.
Then we can subtract 9y. Subtract 9y. We can add 2. We can add 2, and we get y is equal to
9.
And that's one of our answers. This is where the C student stops, and then the A student, what they do is they take this and plug it back in to find the pieces of each part that it's looking for. If I want to find GH, we plug the 9 in right there. 7 times 9 plus 3. Do you know what that is? If I want to find HI, it's 3 times 9 minus 5. What does that make?
22.
22. And then GI is the full distance, right? And here's what I'm going to do. Let's put these two numbers together. What's 66 plus 22?
88.
That should match 9 times 9 plus 7. Is that the same thing? You sure?
Yes.
9 times 9 is 81 plus 7 is... It does work. We could add them this way or this way, should make the same number. The last example that I have for you, let's turn this over. I believe it looks like either number 20, I think it is. NO is 17, NP is 5x minus 6. You need to find x, NP, and OP. And then there's a picture that looks something like this. N, O, P, R, Q. In case you forgot, if there's 2 bars and 2 bars, it means that this piece is congruent to that piece. If there's 1 bar and 1 bar, it means this is congruent to that piece, but they're not necessarily congruent to each other. So what I would do if I were you, and they told me that NO is 17, I would put that in your picture. This piece is 17. Well, if that's 17, then what is OP equal to? What does this have to be?
17.
Is that one of the questions we have to answer? So now that you've figured out what this piece is, can you figure out what the distance from N to P is?
Yeah.
What is that distance?
34.
And do we know what X is yet? No, not necessarily, but we know that NP, this full distance, is 34, and that equation, 5x minus 6 is equal to 34. We can solve it for it. And X is equal to 8. We'll stop our notes right there.